Well, we'll go ahead and get started on homework 5, since we're behind from last week as it is. First one's here, writing an inequality for a real-world situation. So you're just going to use the greater than, less than or equal to, or greater than or equal to, depending on what it says. It says the cargo of a truck weighs no more than 2,300 pounds. When it says no more, think of it as like it's not more. So if it's not more than 2,300 pounds, it could be less than, but it also could be equal to, because if it's equal to, it's not more, right? So in this case, we got to use W to represent the weight in pounds. So W is going to be less than or equal to 2,300, and that's how they want us to translate that. The temperature inside the lab refrigerator is less than the 40 degrees Fahrenheit. Well, this one's pretty straightforward. It just says is less. So T is going to represent the temperature. The temperature is less than 40. And we're not going to put any labels or marks on them, just the straightforward inequality on that. So on the second one here, it says Carmen exercises at least 45 minutes a day. So if it's at least, that's the minimum amount she exercises. She could have exercised more than that. So T is my time. I'm going to use greater than or equal to. It could be the 45 minutes that she exercised, but it could be more than that when we use at least. The distance to the nearest exit door is more than 100 feet. Well, this one's pretty straightforward. It's more, so it's greater than. So D is greater than 100. So the temperature inside the lab refrigerator is at most 45. Is at most. What symbol do you think you'd use if it says is at most 45? Less than or equal to? Yes. 45 is the most it can be, but it could be less than that. So T is less than or equal to 45. The cargo of the truck weighs no less than 1,000, so if it's no less, we would use more than or equal to, greater than or equal to. So no less, it's not less than that, but it still could be equal to that. So W is greater than or equal to 1,000. So those are some of the common ones. If you go to Linda's note sheets, I have a little table there with a few more others in there that you can print out or just keep track as you go, thinking about what those words mean. The next one, we're just basically graphing our inequality on the number line. If we have the less than or the greater than without the equal to, we're going to put a circle around that number showing this is my starting point, but I'm not exactly on the number. If it does have the equal to bar underneath, then we use the filled in dot. That means we are equal to the number and anything bigger or smaller depending on what we're doing. So if I'm going to graph the inequality on the number line, B is less than -9. I'm going to click on the open circle, click right on the -9 so that there's an open circle around that -9. And then when I shade less than, look at the end of your number line. Notice my less than symbol points that way and the end of my number line points that way. I'm going to click anywhere between my circle and the end of my number line, and it's going to fill in everything less than -9. Amy, you want to grab a new day 5. I noticed there are a couple topics that evidently I just skipped right over when I typed it up. And then the chapter 1 packet's also there. So on number 5, we're graphing the inequality that says x is greater than or equal to -3. Since it has the equal to bar, we're going to use the filled in circle on -3. And then again, if you look at your greater than symbol, it points this way. The end of my number line also points that way when I go to the right. So I'm going to click anywhere between my dot and the end of the number line. and it's going to shade, boy, I drew that pretty straight, everything that's greater than my negative 3. So number 6, if I want to graph A is less than 2, what kind of end mark should I have? Should be the open one, and should I shade to the left or to the right of my dot? To the left. Less than points to the left. That's the way my arrow on the end points, and so my graph looks like that. 7, 8, and 9, we are trying to rewrite these as compound inequalities. We're going to put the variable in the middle, and we want the x or whatever variable we're working with to be between our two numbers. When you do that, both your signs end up either being both less than or both greater than, depending on if you're going from smallest to largest or largest to smallest. Might have the equal to underneath. But what I'm going to do is first just translate them separately. Negative 8 is less than x. And 4 is greater than or equal to x. So what I want to have happen is for my x's both to be in the middle. I'm going to leave this one in the order it's in because the x is in the inside, but this one I'm going to flip the other way around. If 4 is greater than or equal to x, then x has to be less than or equal to 4. Now I'm just going to smush those two statements together. Negative 8 is less than x, which is less than or equal to 4. Notice I'm going from smallest to largest, so both of my symbols point to the left. They're both less than or equal to. If I look at number 8, translating them each separately, 3 is greater than b. 3 is greater than b. And negative 8 is less than or equal to b. So again on this one, if I put my b's both in the middle, I'm going to flip that second one around. If negative 8 is less than or equal to b, then b is greater than or equal to negative 8. And if I rewrite that, 3 is greater than b, which is greater than or equal to negative 8. Notice on this one I went from biggest to smallest, so I have greater than symbols in there. But they should always both end up pointing in the same direction. If you've got one going one way and one going the other way, it's not possible for the x to be in the middle. So they both have to end up pointing in the same direction. So number 9. V is greater than negative 1. Or no, that's a y. My squiggle always looks like it cuts things off on the bottom. Y is greater than negative 1 and less than 8, meaning y is less than 8, right? Y is greater than negative 1 and y is less than 8. So in this case, which one of those two things should I flip around? Which one? This first one, yep, with negative 1, because I want to start with the number, right? So 1 is going to be less than, or negative 1 is going to be less than y if y is greater than negative 1. Now my y's are both in the middle, I can put my two expressions together. Negative 1 is less than y, which is less than 8. And there's my compound inequality. There. Oh, Kenyon, good morning. Over on the side, you're going to want to grab a day 5 thing because I skipped a couple topics, and then the new packet. So over there where you sign in if you want to grab those. So when we graph a compound linear inequality on our number line, if it has or between them, you're going to go in the two opposite directions. I'm going this way or this way. If it says and, you're going to shade in the middle. It should just be between my two numbers. So, what you're going to do on Alex is put your two end marks on your number line first before you try to do any of the shading. X is less than or equal to 0. Going to have the solid dot because it has the equal to right on the 0. x is greater than 5. That one's going to have the open circle because it doesn't have the equal to. So if I'm less than 0, I'm shading to the left of 0. If I'm greater than 5, I'm shading to the right of the 5. It had or in the middle. I should be shading the 2 outsides. I did. So it looks something like that. Number 11 says x is greater than or equal to negative 2. So on the negative 2, what kind of end mark should I have? The filled in circle. And then we have x is less than 5. So on the 5, we're going to have the open circle. And if x is greater than negative 2 and less than 5, we would shade right in the middle of those 2 dots. I'm bigger than the negative 2, but less than the 5, so I'm between the 2 numbers. Number 12, again we're graphing our compound inequality. X is less than or equal to negative 2, or x is greater than or equal to 5. So, what kind of dot should I have on my negative 2? Filled in circle. And what kind of dot should be on the 5? Filled in circle. And now on this one, where should we shade? To the left of the negative 2 and the right of the 5. So I'm on the 2 outsides because it's an or, going this way or this way. Now these are the ones, for some reason, when I typed up the note sheets, I just thought I'd skip over these, but hey, figured you might want to have some examples of these ones. So number 13 says set builder notation. Rewrite the set H by listing its elements. Make sure to use the appropriate set notation. This is read H, which is the name of my set, is equal to x such that, and then they're applying these rules to that variable x. X is an integer and negative 4 is less than x, which is less than or equal to 0. In other words, the x is going to be between those 2 numbers. I'm not equal to the negative 4, but I am equal to the 0. Usually if I'm between 2 numbers, what I do is I just start and I say, okay, negative 4, negative 3, negative 2, negative 1, 0. Those are all my possible numbers. And then I look at the ends. If I'm not equal to one of the ends or both of the ends, I'm going to cross them off. In this case, I'm not equal to the negative 4, so I'm going to get rid of that from my list. I am equal to the 0, so I'm going to keep that one. It then also says that you have to use appropriate set notation. So you're going to have set symbols around your answers with commas in between each of your numbers. And so your answer will look something like that. So on number 14, we're going to rewrite the set U. Here's our set U. Using the appropriate set notation, y, such that y is an integer, a nice whole number, and negative 4 is less than or equal to x, which is less than negative 2. So again, since the x is between my 2 numbers, I'm just going to list all my possibilities. Negative 4, negative 3, negative 2. And then I check my end marks. Do I keep the negative 4? Yep, because it has the equal to. Do I keep the negative 2? Nope, it doesn't have the equal to. So I'm going to get rid of that. Just have those 2 numbers in my set. So negative 4 and negative 3 would be my answer. Now if we go to number 15 there, here's one where the x isn't between 2 numbers. It says rewrite the set W by listing its elements. Make sure to use the appropriate set notation. So W is my set. Z such that, Z has to be a nice integer, and x is less than or equal to 3. So when I do my set here, I'm just going to start listing at least 3 elements in my set. So I am equal to the 3, that's my starting point, and I'm doing the numbers less than that. So 3, 2, 1, if I wanted to put 0, I could do that. But then it keeps going and going and going and going. You have to put a comma behind the last number that you use, and then there'll be a little choice that has 3 little dots. Their ellipses means it keeps going and going and going and going. And so you'll have a set that looks something like that. But you have to have at least 3 numbers. You can do more than 3, but minimum is 3 to show the pattern. And then we have set builder and interval notation. Interval notation is used in higher level math. It means the same thing as the inequality stuff, but it's a shorter way to write it. If you have the filled in dot, you're going to use a bracket. A bracket and the filled in dot means you're equal to that number. If you have the open circle or infinity, you're going to use a parenthesis. The open circle means you're not on that number exactly. And infinity you never can get to, so you use a parenthesis on it. So, first thing they're going to have us graph the set, x such that negative 2 is less than or equal to x, which is less than 0. So, the negative 2 is going to have a filled in dot because we have the equal to. The 0 has an open circle. The x is between those two things, so I'm shading between my 2 dots. In interval notation then, I went from negative 2 to 0. I'm just using my starting number and my ending number from left to right, and then the appropriate end mark. This had a filled in dot. I am equal to the negative 2, so I use a bracket. This had an open circle. I'm not equal to the 0. I use the parenthesis. And so this means the exact same thing this does, but it's a shorter way to write it. Number 17, then it says graph the set 1 is less than x, which is less than 7 on the number line. Write your set using interval notation. Again, the x is between my 2 numbers. I'm not equal to the 1, so I have an open circle. I'm not equal to the 7, I have an open circle. The x is between those 2 things. So in interval notation, my interval just goes from the 1 to the 7. I'm not equal to the 1, so what kind of end mark should I have? The parenthesis. And I'm not equal to the 7, so I also have a parenthesis. So on that one I have parentheses on both ends. Now what happens when I have a set that doesn't go between 2 numbers? It either goes to negative infinity or positive infinity depending on which direction you're going. This end of my graph is positive infinity. This end of my graph would be negative infinity. So I always go from left to right. So if it was a less than, I'd start here. If it's a greater than, I end over here. So in this case, x is greater than negative 1. Open circle on the negative 1. I'm doing everything greater than that. And so my interval from left to right starts at the negative 1 and goes to infinity. Negative 1 happened to have an open circle, so it's going to have parentheses. Infinity, always going to have parentheses because you can't really be on infinity. And so my interval goes from negative 1 to infinity. And just for fun, if I just write one up here, just so you have an example, if I would be doing x is less than or equal to negative 3 for fun, on negative 3 I'd have a filled in dot, and in this case I'm going this direction, and so my interval when I'm doing that less than or equal to is going to go from negative infinity to the negative 3 because I always go from left to right. This is going to have a parenthesis because I can't be on infinity. This end has a bracket because it does have that filled in dot. I am equal to that negative 3. So that would look something like that. And again, if you look at Alex's notes or my notes, there's going to be a little table with all the different ways it could be and all the different ways you might be writing your interval. Then it hops over probably to a different section of your pie chart and has you do a couple little problems over there. First one is ordering fractions with variables. Suppose A, B, C, and D are four numbers which satisfy the conditions A is greater than B, B is greater than C, C is greater than D, and D is greater than 0. Fill in the blank boxes using either greater than, less than, or equal to make each expression a true statement. So this one I just totally redid the Alex explanation because they're sitting there looking at A, B's, and C's trying to figure out the answer and it's way too confusing. What you want to do is put numbers in for your A, B, C, and D that make that a true statement, and then you can use those numbers. I'm going to work my way backwards. What number is bigger than 0? 1, right? You could use a bigger one than that if you really wanted to, but just to keep it easy, we'll just put a 1 there. What number is bigger than 1? 2. Then we have 3, then we have 4. So A is going to be 4, B is going to be 3, C is going to be 2, and D is going to be 1. They're not going to change that condition on Alex. It's always going to be that same condition. So you can always just use those same four numbers for A, B, C, and D, and then compare your fractions. So A over B would be the fraction 4/3. If I wanted to, I could rewrite it as a mixed number, 1 1/3. A over D. A over D would be 4/1. Well, that's just 4 then when I simplify that. 1 1/3 compared to 4, well, that's pretty easy to compare. Hopefully we know 1 1/3 is less than 4, right? On the second one, D over B. D over B would be 1/3. B over D would be 3/1, which is 3. Again, comparing 1/3 to 3, well, that's now pretty easy to do. We know 1/3 is less than 3. The next one, D over A. D over A would be 1/4. C over B. C over B would be 2/3. Now you might already know the answer when you compare 1/4 to 2/3, but if you didn't, what you'd want to do is make a common denominator. If I made a common denominator on this one, I have a 4 and a 3, I'm going to use 12 then. 3 goes into 12, 4 times 2 is 8. Over here, 4 goes into 12, 3 times 1 is 3. 3/12 compared to 8/12, less than. 1/4 is less than 2/3. You probably already knew that, but just in case you didn't, that's what we want to do, is make our equivalent fraction, and then it's pretty easy to compare. So number 20, same directions up on top. A, B, C, and D are four numbers that satisfy the condition A is greater than B, which is greater than C, which is greater than D, which is greater than 0. So again, if we just use these same four values, D over B would be what fraction? 1/3. A over C would be 4/2, which simplifies into just a 2, right? So 1/3 compared to 2, we know is less than. C over D would be the fraction 2/1, and 2/1 is just 2 when we rewrite it. D over C would be the fraction 1/2, 2 compared to 1/2. Okay, we got a greater than. D over B would be 1/3. C over B, 2/3. 1/3 compared to 2/3, less than, right? 1/3 is less than 2/3. Number 21. Same rules up there. Again, we're going to say A is 4, B is 3, C is 2, and D is 1. And so B over D would be 3 over 1, which is 3. D over B would be 1 over 3. And 3 is greater than 1/3. Big N by the big number. A over C would be 4 over 2, which is 2. A over D, 4 over 1, which is 4. 2 compared to 4, less than. C over B would be 2/3. B over D would be 3 over 1, which is 3. And 2/3 compared to 3, less than. So it makes it pretty easy once you start throwing those numbers in there instead of just trying to look and say, oh, if A is bigger than B, then this has to be true, and da-da-da, like they do in the ALEKS program. And the last one's square root of a rational perfect square. If your numbers are perfect squares, you're just going to go ahead and take the square roots of your numbers. If they are not perfect squares, you're going to reduce the fraction down first, and then you should have perfect squares that you can take the square roots of. 27 over 75. Well, 27 and 75 are both not perfect squares. I can't just do the square root of 27 and get a nice whole number. But if I happen to divide them both by 3 and reduce my fraction down, still under the square root, 27 divided by 3 is 9. 75 divided by 3 is 25. Now they both end up being perfect squares, and I can take their square roots. The square root of 9 is just the nice plain whole number 3, no square root over the top of it anymore. The square root of 25 is the nice whole number 5. You always want to check at the end, is your fraction in simplest form? In this case it is. 3/5 can't be reduced. And so that's just going to be my answer. Number 23, 16 and 25. Oh, those are both perfect squares, and besides the fact I can't reduce that down anyway, even if I wanted to. So I'm just going to do my square roots. The square root of 16 is 4. The square root of 25 is 5. Can't reduce that fraction, so 4/5 is just going to be my answer. And number 24, 48 and 27 are not perfect squares, but I can divide them both by 3, right? So if I reduce my fraction down, 48 divided by 3 would be 16. 27 divided by 3 is 9. So now I have values that are perfect squares. The square root of 16 is 4. The square root of 9 is 3. And so 4/3 is going to be my answer. They're not going to want the mixed number answer for those who like to grab their calculators all the time. They'll want the improper fraction answer, 4/3. And that should be the end of everything that's in our review. So if you hop over to your ALEKS pie chart, I have to log back in. So log into ALEKS if you're not. Waiting. It's waiting, waiting, waiting. Hopefully when they come this afternoon, hopefully they will come this afternoon. They didn't come last week. VentureCom's supposed to be putting in some new cable or something. Hopefully that will straighten out all our slow spots. If you go to your report for your pie chart, Annette, do you care if I use yours for an example? I can do that? it'll look something sort of like this. Now she doesn't have near as much time as I would like to see, but that's okay because her progress is good. She has 6 topics that are due today to finish the review section, and so hopefully in the next half hour or so she can get those 6 things done that we just covered today, and then she'll be right on track to start chapter 1 here shortly at about 10 o'clock. So you want to look at your pie chart. Now keep in mind the beginning stuff is easier, so we probably want to put a little more time in each week, but for now I'm looking here and saying, yeah, you're right on track of where we're at in class, so that looks great. So check that out, see where you are. You want to, by 10 o'clock, try to get all those topics done, and then we're going to start chapter 1.